There are a handful of dinosaurs that can be recognized by anybody the world over. Popular culture has helped to bring a series of dinosaurs to the forefront of the imagination of the general public when the word dinosaur alone is mentioned. Many of these dinosaurs are animals of the late Cretaceous, theropods such as Velociraptor and Tyrannosaurus, made famous through the likes of the Jurassic Park and subsequent Jurassic World film series. Others are ornithischian herbivores, such as the three-horned Triceratops or the crested duck-billed Parasaurolophus. All of these are dinosaurs that existed towards the very end of the Mesozoic era, and some of them would have witnessed the ultimate destruction of their own kind for themselves. It is strange, then, that only a handful of the most famous dinosaurs ever are actually from the Jurassic period. In this time, where dinosaurs were first able to truly diversify into a huge number of strange new shapes and sizes, did we see the advent of some of the most recognizable of all prehistoric animals. Large theropods such as Allosaurus appeared on the scene, along with long-necked sauropods such as Diplodocus. One dinosaur, however, stands out from the Jurassic crowd as being one of the most famous and well-represented dinosaurs, full stop. Stegosaurus. The name alone should invoke a strong image of a large, bulky, quadrupedal herbivore, a huge torso ending in a tiny head, identifiable by two rows of pointed plates running down its back, and a long tail armed with 4 spear-like spikes. This is a staple of museums, dinosaur documentaries, books, and plastic toys the world over. However, as we will be exploring in today's video, there is much more below the surface that can be examined within this awesome feat of evolution. Today, we will be taking a deep dive into the life, evolution, and discovery of Stegosaurus, examining just how it used its strange adaptations to flourish in the unpredictable and ever-changing world of the Jurassic. We will look at where it lived, how it became extinct, and how it was ultimately dug up by scientists millions upon millions of years later. Join us as we travel back in time to witness the incredible world of Stegosaurus, the most famous dinosaur of the Jurassic. Even amongst the Stegosaurus, a group of dinosaurs characterized by their large bodies, spiked tails, and plated backs, the 3 known species of Stegosaurus, that is Stegosaurus stenops, Stegosaurus ungulatus, and Stegosaurus sulcatus, are easy to identify. Stegosaurus stenops, the type species, measured a lengthy 6.5 meters from nose to tail, and weighed in at a massive 3.5 metric tons. This weight was supported by 4 pillar-like legs and balanced out by an incredibly long tail. The animal's distinctive plates ran in 2 rows from the base of the skull to near enough the tip of the tail, before stopping to make way for the 4 iconic tail spikes, one of the most formidable defense tools in all dinosaur evolutionary history. Let's start with the skull and work our way backwards. The skull of each species of Stegosaurus was thin and elongated, and noticeably small when contrasted with the bulk of its giant torso. The skull was set rather low on the animal's body, and it would not have been easy to move the neck up and down. From this, scientists have been able to discern that Stegosaurus was a browser, not a grazer, and one that took plant matter from shrubs and ferns close to the ground. Take a look at the skull, and you'll notice that the tip of the snout, and along with it the entrance of the mouth, is toothless. In fact, it forms a strange beak-like structure, similar to those seen in hadrosaur dinosaurs, and later some species of birds and turtles. This beak-like structure would have been used to shred the edible matter from vegetation, allowing the dinosaur to chew the food with its small, flat teeth once it had already been stripped off into manageable bite-sized pieces. It is thought that, at least amongst most Stegosaurus, such a function was unique to Stegosaurus, and it may have only emerged on a few separate occasions in its relatives. Many older dinosaur books will quote the fact that Stegosaurus was perhaps amongst the least intelligent of all dinosaurs, given its tiny brain case size in comparison to the animal's massive body. Proportionally speaking, Stegosaurus did indeed have one of the smallest brains of all dinosaurs. It weighed no more than 80 grams. In the 1880s, when this information was brought to the attention of the media, it did very little for the progression of the general public's image of dinosaurs. They thought if Stegosaurus's brain was tiny, it must have been dim-witted and slow-moving, and the same was thought for almost all dinosaurs as a result. There is unfortunately no way of telling exactly how intelligent this dinosaur actually was. The brain was indeed tiny, yes, but we know relatively nothing of its structure. Without this information, we cannot confidently deduce just how smart, or dim-witted for that matter, this dinosaur could have been. Stegosaurus's vertebral structure can be divided up into a few different segments. 10 cervical vertebrae made up the neck of the animal, which then followed into 17 dorsal vertebrae, making up the back. This was then met with 27 bones in the vertebral column, next to the sacrum, and a total of 46 vertebrae in the tail. These bones are rather consistent in shape right the way down from the neck to the tip of the tail, and they only seem to vary in size, reaching their largest point at the height of the back and the base of the tail. Working our way down past the limbs, the excellently preserved skeletons of Stegosaurus known to science can offer us a good look at the leg and digit structure. The forelimbs were relatively short and thin in comparison to the wider, longer hind limbs, and this mismatch in size led to the dinosaur's strange posture. The hind limbs helped to hoist the tail high above the ground, while the head and neck were forced much lower down. This would have allowed for efficient grazing, pairing with the free use of the tail as a defensive tool. The hind feet of Stegosaurus possessed 3 toes, whereas the front feet possessed 5, the innermost of each forming a hoof-like structure on each foot. Now, surely the 2 most iconic features of this widely recognized animal, the plates and the tail spikes, deserve their own separate sections. Let's start with the plates. Stegosaurus typically possessed anywhere from 17 and 22 of them, arranged in 2 rows lining the spinal column. They were kite-shaped, the largest of which, the ones sitting over the hips, were capable of reaching over 60 centimeters wide by 60 centimeters tall in extreme circumstances. Contrary to what you might think by looking at a typical Stegosaurus skeleton, the plates were not entirely made of bone, nor were they even attached to the skeleton itself. They were in fact modified scales, known as osteoderms, that projected upwards from the skin on the dinosaur's back. They possessed bony cores which helped to toughen them up, ensuring that they remain upright along the dinosaur's back throughout its life, and on top of this may have sat a tough sheath of keratin. Many modern animals possess osteoderms. Think of the tough, bone-like scutes running down the back of a crocodile or alligator. These, just like those seen in Stegosaurus, are modified scales, with cores of bone protecting the animal. To a hypothetical time-traveling naturalist, Stegosaurus's plates may have proven vital in identifying the 3 different species. It is thought that the patterns of the plates on each species would have differed. Stegosaurus denops, for example, had plates staggered alternately down the spine, whereas other species may have had plates in neat rows lining the back. Just like the patterns of a zebra, no 2 plates in any individual Stegosaurus were the same size or shape. There's no doubt that this was an extremely impressive animal in life then, but what was the function of these plates? Over the years, this has been a hot topic of debate for paleontologists studying the dinosaur. Othniel Charles Marsh, the man who first described Stegosaurus, claimed that they were there for defensive purposes, perhaps forming the basis of an armored layer, defending the dinosaur from attackers. This is now considered an obsolete theory by many, due to the fragility and placement of the plates, but it does persist in small pockets of the community. Famed paleontologist Bob Bacher, for example, suggested in 1986 that the plates of Stegosaurus were the cores of horns that ran along the back. The idea was that they may have resembled the horns found in existing hoofed mammals today, used again to protect the bearer from attack. He even went as far as claiming that Stegosaurus could orient the plates at will, aiming the horns in the direction of an attacker. One of the more commonly accepted theories surrounding the function of Stegosaurus's plates is that they were used as a means of thermoregulation. They helped cool the dinosaur down when it was warm, and assisted with taking in sunlight to warm the dinosaur up when it was cold. This is backed up by the evidence of blood vessel networks persisting within the plates, due to the fact that blood running through these vessels would have been in such close proximity to warm or cold air. It could absorb more of it into the body of the dinosaur, proceeding to transport it around the Stegosaurus's body through the wider blood vessel network. The massive ears of the African elephant species, for example, work the same way. Studies into the osteoderm plates of alligators as recent as 2010 seem to support this theory too. That being said, this theory is not without its arguments. Kentrosaurus, for example, a closely related and somewhat famous stegosaur, did not possess the large kite-like structures of Stegosaurus. Instead, it boasted a row of sharp spikes running down its back. Some paleontologists have interpreted this as an argument against the thermoregulation theory. If Kentrosaurus, whose spikes were too low in surface area to have an impact on body temperature, did not need to warm itself up this way, then why would such a need be important enough for Stegosaurus to specially evolve its plates to assist with it? The debate continues. One further theory supports the idea that Stegosaurus used its plates as a means of display, possibly to warn off an attacker with an intimidating flurry of colors and patterns. Some think that when a predatory dinosaur approached Stegosaurus, the large herbivore could have flushed a great deal of blood into the plates, turning them bright red in color, due to the fact that the plates were not covered in skin. However, this theory seems unlikely. Perhaps then these plates were not used to frighten off enemies, but to attract members of the same species. Christiansen and Chomp, in a 2010 study, explore this idea, stating that the visible surface of the plates would have been increased by the keratin covering, which may have been brightly colored with eye-striking patterns. This is supported even further with the idea that some Stegosaurus may well have been sexually dimorphic. The males look different to the females, as in many modern-day birds. As it stands, we cannot be sure exactly how Stegosaurus used its impressive biological gear, but this last theory seems to be the most unchallenged. So what about the impressive tail boasted by each of the Stegosaurus species? Again, unsurprisingly, the purpose of the 4 large spikes that adorned the long, horizontally held tail have been the subject of debate across the years. There are 2 conflicting sides to the argument. Were the spikes used for display purposes only, or were they used as defensive weaponry? The idea that the tail was used as a weapon came first. Bob Bacher theorized that the tail was presumably highly flexible in life, as the tendons were not hardened. His theory stated that Stegosaurus would plant itself firmly into the ground with its massive hind limbs, using its smaller but muscular forelimbs to push backwards, orienting its body in such a method that the tail could be used as a swinging weapon, moving from side to side. Further evidence was unearthed when paleontologist Lori McWhinney and her team discovered that nearly 10% of all known Stegosaurus tail spikes possessed injuries or trauma on the bone. This too was bolstered by the discovery of a punctured tail vertebrae of an Allosaurus, a large predatory dinosaur that lived alongside Stegosaurus, often dubbed the Lion of the Jurassic. The vertebrae in question had been impaled by a Stegosaurus tail spike, which entered the tail of the dinosaur from below, displacing part of the bone as it entered. Signs of infection have also been identified on the Allosaurus's bone as a result. There also exists the possibility that Stegosaurus could have used its tail spikes for display purposes or for sparring rivals. Such displays, if they existed, would most likely be highly elaborate, with the dinosaurs waving their weaponry around from left to right. If a display or confrontation escalated, such meetings between rivals could have been incredibly dangerous. As it stands, however, there is much more support for the idea that Stegosaurus's tail was used as a weapon, rather than a means of signaling or communication. Stegosaurus, like many of the dinosaurs described in the infamous Bone Wars, a period of paleontological rivalry between Edward Drinker Cope and Othniel Charles Marsh, has undergone many changes to its appearance over the years as our understanding of it has progressed into modern times. The first Stegosaurus fossils were discovered in Colorado's Morrison Formation in 1876 by Marshall Parker Felch. These bones were fragmentary, the bulk of which were centered around some caudal vertebrae, and were subsequently brought to Othniel Charles Marsh, who formally described them the following year. Marsh's first take on Stegosaurus, however, was very different to the dinosaur you recognize today. He initially believed it to be an aquatic animal, not too dissimilar from a giant turtle, with the iconic plates overlapping on the creature's back to form the basis of a shell-like structure. This is how the dinosaur received its name, Stegosaurus, which translates into English as roof lizard. Marsh would also go on to incorrectly assign a series of other bones from the Jurassic, including the teeth of the huge sauropod Diplodocus and the limb bones of Allosaurus, to Stegosaurus. Further discoveries were made by Arthur Lakes in 1879 in Wyoming, specifically at Como Bluff in Albany County. In the late summer, he traveled out to collect fossils only to stumble across a series of Stegosaurus fossils immaculately preserved in the rock. Building on the first discoveries, Lakes was able to unearth a partial skull, a series of vertebrae, some limb bones, and a few fully preserved plates, and even some tail spikes. An almost complete skeleton was then discovered in 1885, that of a subadult, who revealed to science a complete skull and a full set of backplates. Now that this dinosaur was known in near enough entirety, more in-depth studies could commence. The near-complete skeleton discovered in 1885 has been on display in the National Museum of Natural History in Washington, D.C. since 1915. It is from around this time that the classic image of Stegosaurus was produced, and one that still strays rather far from the truth. Stegosaurus was first portrayed as a lumbering, tail-dragging beast with short, lizard-like legs, 8 spikes on its tail that pointed upwards, and plates that were arranged in an immaculate, almost copied and pasted row on its back. It is this depiction that would become most closely associated with the dinosaur in books, television, film, museums, and even dinosaur toys, something that now looks entirely archaic. Through the subsequent studies across the years, scientists were able to deduce a more accurate form of this dinosaur, one that looked and functioned more like a living, breathing animal than something that would fit better in the annals of mythology. Our modern perception of this dinosaur shows an animal that walks on long, powerful legs, almost like a giant reptilian deer, whose powerful tail was held upright clear off the ground. The plates on its back are arranged in a much more irregular pattern, and only 4 spikes adorn the tip of its tail, held out horizontally to the main stem of the tail. It is this vision of this dinosaur that is, as far as science has taken us so far, the accurate depiction of Stegosaurus. Time will tell whether or not this too can be altered in the future. Stegosaurus is most closely associated with the Morrison Formation, a fossil site from what is today the western states of the USA, centralized mainly in Colorado and Wyoming, with outcrops found in Montana, both North and South Dakota, Kansas, Nebraska, and parts of Texas. Its rocks date from around 156 to 146 million years ago, from the Kimmeridgian to the Tithonian stages of the Jurassic period. Stegosaurus was present on the scene for much of this time, appearing around 155 million years ago and surviving for another 10 million years. Studies on the rocks and plant life of the Morrison Formation have led scientists to believe that in the late Jurassic, Colorado was a vast semi-arid region, similar to the scrubland and open woodlands of Africa. Distinct wet and dry seasons dictated the appearance of the landscape, with rivers forming vast floodplains over certain parts of the land. The forests of the time were primarily composed of conifers, ferns, and tree ferns, with plants such as cycads, ginkgos, horsetails, and smaller ferns making up the undergrowth. Stegosaurus was not alone in the Morrison Formation, and a series of important and often well-known dinosaurs shared the land with it. Herbivores, often of the gigantic variety, were commonplace, with huge sauropods towering over the land. The sauropods of the Morrison Formation are in fact the most famous sauropods ever to live, and alongside Stegosaurus would have walked the likes of Brachiosaurus, Diplodocus, Camarasaurus, Apatosaurus, and Barosaurus. Many of these dinosaurs were able to reach the top of the trees that Stegosaurus was unable to feed from, meaning that competition for food sources was not a problem. While it is easy to think of sauropods as similar, given their massive sizes and long necks, the sauropods of the Morrison Formation display dramatic differences. Brachiosaurus, for example, held its comparatively small body upright, with huge forelimbs and a neck that projected high into the air. Diplodocus held its body more horizontally, with the neck and tail allowing for the massive animal to balance its tremendous size. Camarasaurus, on the other hand, was slightly smaller and bulkier, mixing a more upright posture with a long neck and tail. Other ornithischian dinosaurs shared the landscape with the various species of Stegosaurus. The most famous of these is Camptosaurus, a genus of beaked herbivore that was commonplace in the area which it lived. Some of the earliest Ankylosaurus lived here, including the very well-known Gargoylosaurus. Many of the ornithischians here were much smaller than Stegosaurus, composed of relatively diminutive bipeds, such as Dryosaurus, Othnilosaurus, and Drinker, the latter two of which are named after the men involved in the Bone Wars, Othniel Charles Marsh and Edward Drinker Cope. The Morrison Formation was not without its predators, however, and a series of very well-known theropod carnivores thrived here too. Allosaurus is by far the most well-known, a genus of large Carnotaurus, known for its concave vertebrae and a small crest above the eyes. This dinosaur is often depicted as a pack hunter, and was likely one of the predators that could, perhaps with a little difficulty, take down a Stegosaurus. Closely related was Saurophaganax, so similar in fact that some paleontologists consider it to be a species of Allosaurus. Torvosaurus, Ceratosaurus, and Marshosaurus added to this roster, making up a series of Morrison theropods belonging to the Megalosauridae clade, while smaller theropods, such as Ornitholestes, Coelurus, and Tanicolagrius stalked smaller prey through the forest undergrowth. Amidst the colossal and iconic dinosaurian fauna of the Morrison, a plethora of other creatures went about their daily lives. Lungfish skulked in the gentle river waters, accompanied by early frogs and salamanders. Reptiles, including lizard-like Sphenodontia, climbed trees and basked on rocks in the midday sun. Pterodactyloid pterosaurs soared overhead, perhaps scooping up fish from the rivers, while little mammals darted in and out of the undergrowth, perhaps chasing insects and other invertebrates. If you look a little closer, it was a particularly diverse world. Stegosaurus sits within the family Stegosauridae, within the clade Stegosauria. Stegosauria also contains Huayongosaurus, and all dinosaurs that are more closely related to Stegosaurus than Huayongosaurus accompany the former in the Stegosauridae family. The entire family is named after Stegosaurus itself, but Stegosaurus was by no means the first to appear. These dinosaurs were in existence from the Middle Jurassic right through to the early Cretaceous, and throughout this time managed to span North America, Africa, and parts of Eurasia. All of the dinosaurs within Stegosauridae bear many similarities to Stegosaurus. They were quadrupedal herbivores, with large dermal plates running down their backs. They possess spikes jutting out horizontally at the tip of their tails, and their heads were generally very small compared to the immense size of their bodies. as of 2017, when Raven and Maidment published their new phylogenetic tree of the Stegosauridae family, it was determined that the closest relative to Stegosaurus was a dinosaur genus known as Wuerhosaurus. This dinosaur inhabited the forests of early Cretaceous China and was one of the last stegosaurs to exist. Unlike Stegosaurus, the plates lining the back of Wuerhosaurus were shaped like short rectangular blocks, and its body was held much lower to the ground than earlier Stegosauridae. The next most closely related dinosaurs to Stegosaurus are Hesperosaurus and Miragaia, the latter of which was known for its exceptionally long neck for a stegosaur. As we explore the remainder of the family, exceptional diversity becomes apparent in the dinosaurs related to Stegosaurus. Perhaps the second most famous dinosaur in the family is Kentrosaurus, a stegosaur known for its thin, spine-like back plates, inhabiting what is now Tanzania in Africa during the late Jurassic. Other genera include Dacentrurus, known from England, Gigantspinosaurus and Jiangjianosaurus, known from China, and Loricatosaurus from France. All of these dinosaurs were members of the larger clade known as Thyreophora, which contained both the Stegosaurus and the Ankylosaurus. As one of the most famous dinosaurs ever to walk the Earth, it is unsurprising that Stegosaurus has had a massive cultural impact on the world it inhabited. Firstly, take into account just how universally recognizable this dinosaur is. Whether you're an avid dinosaur enthusiast or somebody who only roughly knows what a dinosaur is, you can likely recognize Stegosaurus. It has been depicted in media the world over, from film and television to comics, books, toys, and even games. Many of the most memorable depictions of Stegosaurus in the media come from before the 2010s, when our perception of this dinosaur was still outdated. And as such, this has had long-lasting impact on how the general public see this dinosaur. In terms of specifics, Stegosaurus has been mentioned in books such as The Lost World by Arthur Conan Doyle and Jurassic Park by Michael Crichton, both of which have gone on to become some of the most important pieces of culturally significant dinosaur literature the world has ever seen. In television and film, Stegosaurus has been depicted in the 1933 edition of King Kong, Disney's Fantasia, Jurassic Park, Jurassic World, The Land Before Time, and Walking with Dinosaurs. It is one of the most well-documented dinosaurs across our culture, and one that will likely be depicted for decades, if not centuries to come. Stegosaurus is a fantastic example of how our understanding of dinosaurs can change so dramatically over the years following its discovery. Taking a look at the very first depictions of Stegosaurus as a large, long-necked, turtle-like animal with spines running down its back like a porcupine, the dinosaur is almost unrecognizable to the graceful form of the modern day. While the same can be said for many of the dinosaurs first unearthed in the legendary Bone Wars, it begs the question, how much more do we have to learn about the dinosaurs we think we know today? There is no doubt that paleontology has come leaps and bounds since the time of Edward Drinker Cope and Othniel Charles Marsh, but there are without a doubt thousands of discoveries left waiting to be made, both in the deep confines of the Earth and in the specimens already known to science. How much more do we have to learn about Stegosaurus, in fact? Could it be that in the future, we discover exactly what this dinosaur might have looked like in life, right down to the colors of the plates. It's not out of the question. Take a look at some of the spectacular feathered dinosaurs that have been unearthed in China's Yixiang Formation, and the true colors of the dinosaurs, literally, are starting to show themselves. Some of the colors of these dinosaurs have not come from feathers, but from the skin itself. Ornithischians such as Stegosaurus, for example, are so well known that we can recreate a near immaculate depiction of them. Time will tell, but perhaps one day we will know even more about the iconic and spectacular Stegosaurus and its relatives. Either way, this is a dinosaur that has brought us, as a society, a wealth of information, and subsequently cultural impact on the media we enjoy. As more and more is unearthed, and we learn more about this dinosaur and its way of life, who knows where this could lead?